Yes, I can see your screen.
Okay. So let me see what I have seen yesterday. Uh, okay. So basically, like this is the only matter one, right? All of the other, it's just like a long explanation. It's not. It doesn't matter, right?
Uh, no, in practice, not it doesn't matter.
So now I understand, like I only need to like apply this formula down there. Like I was so concerned about like all of these parts, like what the hell is it, so that's why like I wasn't be able to understand and carry on at all. So okay, now I understand. So
Okay.
I got what I supposed to do. So I'm so glad I finally can move on with that. So basically what I think I'll do now. So okay, so I have a list of dice and I roll each die in the list, and I get an outcome. It's not a list or outcome, but just an outcome. So see, okay, see, so I get an out. So for example, if I have the list of dice like 5, 3, 7, and I roll each dice in the I roll an outcome, for example, 7, because in the example, no, let's do 6, because in the example, we only have like one outcome. We didn't have like multiple outcome like here. So we only have one outcome. So 6. And I need to see like, uh, first I
If
need to
you
see.
roll, if you roll dice, you will have three outcomes.
Oh, but then why in here like it's only have, oh, because it take the largest one, right?
No, they didn't take just the last one. They take any value. In this case, it is 8. The second case is 1. Any value, the number of
Oh,
face.
okay. So take any random outcome.
Yes, any possible random outcome.
Mm-hmm.
Oh, no, don't write it.
Take any random outcome.
Okay.
6, right? And see which um and see which of, so see which outcome it could belong. Uh, so for example, the six outcome would only can belong to the 7 dice, right? Because all of these here, like it only go up until 5 at the max, so it's only can belong to the 7 dice, and calculate
Yeah.
the probability of the probability of the dice uh, coming out as come out. So so basically, what it asks is that it's actually like when is how what is the possibility of the dice come out at 6, right, in the 7 dice. So it could be like how did I solve it yesterday? So calculate the probability of the dice come out at 6 in the 7 dice, right? Is it correct?
Calculate the probability of the dice come out as 6 in the 7 dice. Yes, it is. But it's not the probability they are asking you for.
Oh, it's not. So what should I calculate?
I don't know why you remove what we wrote the last time. You should let it what we
Okay,
wrote.
it's too late now.
No, make a lot of Control Z, Control plus Z.
Pardon?
Make a series of Control plus C
Oh, okay.
on your keyboard.
That's too long. That's too much because we reach into this step like because basically the what I wrote is correct, right? It's not wrong, right?
No, it's not correct because the last time I gave you the steps of the experiment. Now what you are trying to do is to give the steps for solving the problem. See the steps are different.
No, I need to know like the steps to solve the problem so that I can start writing the code.
Okay, we can do it, but if you
Yeah.
try first you
Yeah,
get a list. It's not only
because
a list you get at the beginning, you get another parameter too for solving the
okay,
problem.
okay,
You get a list of dice and a random value, a random outcome. Go to the doctrine to see how the definition they give for the second parameter below in the function.
pardon?
Go below in the function to see how they define the second parameter. Variable tab right. A list of integer and m max an integer. This integer could be any possible number on the face of each dice. So go scroll up. Yeah. So at the first step, you get a list of dice and a possible outcome. You can change have a list of dice and a possible outcome.
I'm not sure. I'm not on the. Where is it?
At the first step, have a parameter of dice instead of writing have a parameter dice
Yes.
of dice.
Yes.
You get a list of dice and the parameter have a list of dice and the possible outcome. And not of possible outcome and a possible outcome.
Where is it? Oh. Sorry, where is it?
Yeah, just after a list of dice instead of writing off right end.
Here, I'll give the remote control for you. Yeah, at your side there's some noise. So, oh, sorry.
Uh,
That's all right, and right.
yeah.
Okay, I get that is the end. That's all right.
Okay, let's move it.
Okay.
Next step.
So mm,
For each dice, you should compute the probability that you should compute two probability for each dice.
oh, so
First is the probability that
MX, I think your voice there's some weird statistic, some weird static noise again at your side. It was.
Can you hear me better?
Can you say, that's all right. Yeah, I think it's all right now.
Okay, great. I was saying that after you have a list of dice and possible outcome, you roll each dice in the list. You take any random outcome. No, don't take any random outcome. After you roll each dice in the list, you record each outcome. So you got a list of outcome. You got a list of outcome. Instead of writing, okay, write it. My keyboard is not working well today. I don't know why.
Oh, maybe I can let me let you editing at your side, so you can edit it. Here, so you would be able to edit at your side. So I'll stop share, then I'll look at your screen and ask on that part. Is that all right?
Okay, good. Already shared it. Okay. Do you see my screen?
I'm still waiting for it. A little bit.
You don't see it yet.
No, I haven't see. I only see. I think I see you are in the chat, but I
I think
haven't see the notebook yet. Oh, okay.
we should
Yes, I
see
see
it.
you.
Okay.
You type gmail.com, right?
Yeah.
Okay, yeah, I'll be able to see.
Right.
You now.
Okay, great. So that is mine.
Okay. Oh, I think. Let me share with you then.
Okay.
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 Yes.
It is slow. Okay. 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 Okay.
Are you able to access it? All right. Okay. You see it now.
Yeah.
Yeah.
I restart my computer. Oh, wait.
Yes. Hello?
Let me restart my computer.
Okay. Okay. Sure. Hello? You're gonna restart your computer, right?
So we are here. Got the list of outcome. Could you give me a possible outcome with this
Okay.
list?
So 3, 5, 7. So we have the list. So for example, in the 3 dice, we have in the 5 dice that we would have like 5, 2, 5, 3, 4, 5, 4, 3, 2, 1, 5, 4, 5, 4, 3, 2, 1, right? So those are the
Okay.
list of outcome. Oh no,
Okay.
it's not a list of outcome, is it?
Yeah, it is a list of outcome.
Okay.
Firstly, we take the outcome, the number appearing at the top face. For this dice, you could get 5 at the top face. The second dice, we could get 3. The second, we could get 4. You agree?
Yes.
Okay. Then after having the list of outcome, we find the maximum value. This is the final outcome. Final outcome is max of this. Okay, max of this. In this case, it is 5. Then we try to compute. Okay.
Okay, so in the step 5, compute the probability that max is equal to any given. So for example, if, but then, okay, so I get the max value of the list, and then I find out whether the 5 is belong to which of the list above, right? To belong
But you don't
to
have,
the dice.
I don't have to compute it. In reality, it's a random variable. So
Yes, but I meant like, do we need to find out that the 5, for example, in our list, 5 is the biggest outcome. So do we need to see like whether the 5 belong to which of the list?
no.
So
You don't need to check.
sorry, I'm a little bit confused. So for example, in here, like the 5 dice, the 5 in the step 4, we have the 5, right? Do we need to go back to step 3 to see that 5 where it's belong to, like whether it belong to the first dice or the second dice?
Wait a minute. I'm thinking.
Because I'm thinking, you know, like when we have the list of dice, like step 1, we also get the max value of each of the, oh yeah, never mind, it's already taken.
Yeah, I see what you are asking for. I understand what you are asking for.
Okay.
Yes, you have to check it before to compute the probability.
Okay.
Because if 5 is not in a dice, you won't get the right probability. Okay. To compute the probability that let's look at is max. That the face appearing at the top is less or equal than M max. Here is it. We take the M max divided by the number of faces. The number of faces is here.
So we need to figure out where that 5 could belong to in the list of dice, right?
So it is simple. So simple. First, as the first step to compute the probability, you have to look proof. Okay. Vas-y. Tu assures. Après, je te revois ça. Ah, je me suis pas fait payer. So, aujourd'hui, je dois me faire payer, mais je suis pas allé. Oh, sorry.
That's all right.
Sorry, Tram.
That's all right. I'm practicing my French comprehensive, listening. French oral.
Okay.
It's all right. Keep talking.
I got it.
I'm enjoying it.
Okay, let's continue.
Okay.
You do proof the values of the list of dice. For each value, at the first step, you compute this probability. Compute the probability of having the top face appearing after rolling be less than after rolling be less or equal than M max. Okay. After computing this probability, to compute it, it is M max divided by okay. See, M max divided by the first element of that list. See what represents the Ki here. You don't see my screen. Yeah, the K1 here, Ki here, it is any element in the list of dice. Each element represents the number of faces. So it is the possibilities divided by the number of faces. Divided by Ki. I think you will understand my Ki.
Okay.
Yeah.
I think I kind of get the concept now. So let me try to code to see.
Okay, you will try and then we'll continue.
Oh, sorry. Is it the last step already, or there is more? Oh, because
there is more.
Oh, okay. Then
No.
let's continue on.
Okay.
Because we still need to apply the function, right?
Yes, it's for the function. That is only the first step.
Oh, okay. Yes.
Okay. After computing this probability, you should compute the second probability. Of having the number of faces after rolling be less than or equal than M max minus 1. It is M max minus 1 divided by Ki. You got it?
Yes.
Okay. After having these two probabilities, you should make the product of the first probabilities. So for it, I think you should instantiate, not instantiate, initialize upper equals 0 and lower. The product of the upper probabilities and the product of the lower probabilities. Okay, so in the loop, you will do upper equals the first probability, this probability, the product of these probabilities. So it will equals to So it's not 0 because it is the product. It's initialized to 1. So it will be 1 times the probability you compute here. You store it, for example, in P up. And this in P log. So we make time P up and lower P log. Now you compute the final probability they ask you, which is the difference between upper and lower. Yeah, that is it.
Oh, okay. Okay, let me switch to my screen now that I'll review it for a little bit. You can start writing code, I think.
Okay, great. Yeah.
I'm starting now. Okay. Go to the value list. Oh, but this formula is different from this formula, right?
Which one?
This one. Oh, hang on, wait, let me. This one.
No, it is the same thing. Just that in this case, they assume that our Ki is a constant. It's always 6 spaces.
Oh, I see. So it's not necessarily 6 spaces. It could be a lot different spaces.
Yeah. So why the value of the list they gave us is different? Each value is the number of the face of each dice. Okay.
Okay, let me see. So oh, okay, it said here. So P1 is 1. Okay. Okay. Let me see. So is it did you write it?
Okay, sorry. I write in on my computer.
Okay, don't worry. Okay, don't worry. Thank you. I'll put these slides. So give me 10 minutes. So let's talk again in 10 minutes. So let me have some time to compute what I get. So let's try to talk again in the 8:25. Is it okay? So we both gonna write some code first.
Okay, great. Ah, GTX Nano.
Non, ça c'est pas G. Non, il y a du GPI, ouais, il y a du GPI. Mais je pense que en fait, ils ont baisé leur de l'achat. Parce qu'ils ont dit qu'il y avait 10 gigas de GPI. Mais je pense que ça ne fait même pas 2 gigas. C'est ça, comment ça se fait. Parce que c'est venu avec le Windows. Dans les paramètres du Windows, je pense que vous voyez 10 gigas. Je ne sais pas comment ils font. Mais dès que j'ai installé mon système de Linux, je ne voyais pas beaucoup d'espace. Je pense que c'est environ les 3 gigas. En plus, parce que je dois configurer ça, j'ai un problème de. Je n'utilise pas vraiment le GPU. Non, c'est pas ici que je fais la défense. Ils ont des serveurs là-bas. C'est là-bas que je lance mes. Quand je lance le connect au serveur, je travaille ici, mais ça a réalité sur le serveur. Et même que là-bas, ils ont beaucoup de CPU. Un serveur qui est appuyé 60 heures. À la fin, il y a plus de 64 de RAM. Donc 64 fois 50, c'est beaucoup quand même. Mais c'est, en fait, le GPI, je ne sais pas, le GPI, c'est tout ce préférable. Il y a un côté rapidité aussi. Tout le préférable de GPI. C'est plus rapide quoi. Oui. Il y a beaucoup de. Je suis venu ici pour bosser sur quelque chose. En plus, si je suis chez moi, j'ai la flamme. C'est un excellent data scientist. On a fait la même promotion ici.
Ça va bien. Ah, putain, je me suis pas. Désiré. Ouais. Ok. Enchanté. Je discute juste avec eux, je ne suis pas. Oh, statistique économique. Et toi, tu fais. Oh. Oui, de quoi? Matriculation. Ok. Faire tout. Une vue d'ensemble de tout. Quoi? Comme ça, il faut. C'est quelle école? Okay. Mais c'est comme ça aussi au Bénin, on a tout ça. C'est pas directement la spécialisation. C'est genre en deuxième ou troisième année que vous commencez à vous spécialiser. Oui.
Oui, ça va.
Oh, Amek,
Yeah, Tram.
I have a question. So here doesn't like it only takes two values, the f and x max, and here is a like input and output. So what is m is f, right? What is f?
M is it. Okay, it is a no. Instead of M, they should say F. M is F, A is max.
Okay, so m is f.
Yeah.
Okay.
M is F, yeah.
Okay.
A is the output.
Okay. So let me see. M max. So M max is equal to X max, right?
No. What is equal to X max, you said?
So here I see like X max and here I see M max. So is M max is equal to X max?
Yes, you're right. Got it.
Oh, okay. Because I see here. Yeah, I still don't understand this. Oh, I have a question.
Yeah.
So why is the -1?
It is a mistake. You should write upper equals 1, lower equals 1. The idea is to initialize the two variables as with one to be able to make the product after.
I'm not understanding it.
You got me?
Yeah, I'm really stuck. Not sure how to compute this step.
Okay.
I'm still really stuck on this.
Yeah. Well.
I saw the code here, but then I'm not sure. Like when I read it, I still don't understand.
Okay. Okay. Wait a minute. You share my screen or I try to explain you this code.
Okay, sure.
What do you prefer?
Oh yeah, please share your screen.
Okay. But I didn't yet solve the problem by my side.
Oh, okay.
I got some errors.
Yeah, don't worry. We can take a look at the same example code too.
Is tomorrow?
Pardon?
What did you say?
Oh, I mean like we can take a look at the example codes and we can try to
Okay,
understand
sure.
together. So
Sure.
okay, so let me share my screen again.
Okay.
So can you see this?
Yes, I can.
Okay, so I don't understand how these people get the answer, but let's try to see if it's correct first. If there's indentations. mode of indentation is so.
I think it will be easier for me to explain the mind because I have done almost the same thing. I just
Okay.
missing the S. I just missing the S break.
Okay. Okay. Let's. So let me stop sharing, and you can explain for me the code.
Okay. So missing this. Mistake. But what I did is I inserted upper to one, lower to one. And the first step, I check if they didn't provide a list without element, without dice. Or if there is a case where the value are trying to see if it is equal, is not a number of a face, I will return a probability of 0. You got it?
Sorry, can you say again?
I try to treat the case where there is a probability equals 0. If there are no dice, or if the number of the X mass is not a number of a face of any dice, the probability will be 0.
Hang on, let me read this. So upper one, lower one. If length of F is equal, can you zoom it in a little bit? Oh, actually, can you copy this and put it in my Colab code so I can read it along with you?
Okay, a minute.
Okay, so let me read along with you. So can I share my screen?
Yeah, you can.
Is equal 1, lower is equal 1. If F length is equal 0, is mass enough in range 1. Why is it plus 1?
Yeah, to be sure that we are counting for all the faces. You see, if in when you use range, if you don't add +1, you won't take in count the last value. For example, if you got a dice of 4 faces, it will take 1, 2, and 3. You won't take the 4th face in account.
Okay,
So if it, yeah.
if length
by the number of faces.
Okay. So for example, if my if my f is only 1, right?
Yeah, if you got only one value, yeah.
Then okay.
So it is only one dice.
Okay, that makes sense. For k in x, if x max is equal to 1, k plus 1. I don't understand this step. Like, well, what is the purpose of this?
Per
Yes.
it is the individual probability. It is the P up is the probability that for that each face this P of x is less or equal than x max.
But this formula is the same, so I don't understand.
Okay, I made the mistake. Instead of x max, I should write x max minus 1.
Oh, okay.
Thank you. Yeah.
Okay, this one, right? Let me see. So P up is equal x max minus k. Okay, what is k? Oh, but then we don't have the value k.
You don't have what?
The value k.
It is the what I use for my loop for k in f.
Oh, okay. I see.
The number of face of the dice.
Okay. So okay. Okay, okay, is dice. Okay, I got this. And P up is x max. So what does it mean?
What?
These two lines.
Yeah, it is the product. You remember I said that the probability is the difference of two products.
Oh.
So the first line is the first product, the second line is the second product.
Okay. So let me go back to the formula. Okay. Okay. So basically, okay. Minus 1. Oh, so you meant like the n, right?
You say?
So you mean like, okay, here, let me copy this formula now. Okay, so we got this, yes. Yeah, so in here, in the last, you said in the formula, so after we get this and this, we don't we have to like power n.
In reality, me, I'm not using this formula. I'm using the generalization that I gave you in my notebook.
Oh, okay. But it's
But it's the same thing. It's just a particular case.
so what is the difference?
Instead of 6, me, I use
Yeah, I got the
you,
6, but then like don't we have to keep the power n?
there is no power n because it's not a constant value. It differs every time. So we can't factorize them.
What do you mean by they differ every time?
What did you ask?
What do you mean by like they differ every time? Because in here n equal 3, right? So if we roll, then that means like they roll 3.
You see this that probability, x divided by 6. That probability is not the same for every dice.
Yes.
For the
Yeah.
first dice, it will be x divided by 3, x divided by 2 for the second, x divided by 8 for the last. So why
Yes.
we make the product? It can
No,
be
I
raised to
understand,
power
but
n.
then
Yeah.
but then I understand like why we don't use 6, but then not like with the n, then we have to like the number of row, right? So we need to keep the n. Then what I'm a little bit confused about.
What I have understood from this exercise is that this n represents the length of the list of dice. It's not the number of rolls.
Oh, okay.
Yeah.
So n is the list of dice, but then we still power here. Like if we would use this formula, then we would still like power 3, right?
Yeah. You read power 3 in that case.
So, but then like in our formula below here, we don't have that step.
We don't have what?
We don't have the n, right? We don't have the power n.
Yeah, it's what I was explaining to you. In our case, we can have the power n because the probability differs. If it's the same value, that could be raised to power n, but it's not the same value every time. For the first time, it is x max divided by k. And this k is changed. It comes from the list F. The first k is not the same value as the second k. The first die could have 2 faces, the second one 3 faces. But in the example, it was always 6 faces. This is why they raise it to power n. You got it?
No, sorry. Can you can you share? Can I let you share screen so you draw it out for me?
Okay.
Okay, thank you.
Do you see my screen?
Yes.
Okay, great. Some explanations. You understand all what I did here?
Let me zoom up the screen. Can you show me again, please?
Yeah.
Okay. Okay.
Okay, you see my screen.
Mm-hmm. Yes.
Okay, you got that formula.
Oh, this is the formula. Okay.
Yeah. Now we assume that
Hello?
yeah, I'm here.
Yes, okay.
Assume that we got P faces. Each dash got P faces.
Mm-hmm.
Right?
Yeah.
We take the example of a list of 4 dash.
Mm-hmm.
Yeah.
Mm-hmm.
We make that product. We need that product. Okay. This one, this is the product from 1 and of our X
Hello?
max. Yeah, you here?
Yeah, I lost you for a second.
Okay. Where do you lose me? Did you lose me?
Yeah, I can hear now. Can you
Okay.
please?
X max. X max equals, for example, 3. Suppose X max equals 3. Okay. Y equal X.
Hello?
Yeah, I'm here.
Yeah, I lost your voice.
You lost my voice. I wasn't talking. Don't worry.
Okay.
So I will try to apply that product in this case.
Mm-hmm.
In applying that product, it is the product of our X max is X, our Ki, it is constant, it is always P. Okay. Minus okay, you got me?
Uh, Let me see. Can you enter so that I can see the, because I'm not used to weak reading. Hang on. Scope assumption. What the same number of phrases? List of 4 dice. Okay, this max equal X. So oh, okay. So because of the loop, okay. So
You see,
yes.
there is
No, but
this
I'm
P,
still
X
confused.
divided by P.
Yeah, so
What?
I'm still confused because why in my original notebook they give a formula like that?
Yeah, they gave a formula. It is that formula I'm trying to explain you.
Oh, okay. Please continue.
You understand it?
No.
You don't understand it?
Uh, yes, I don't understand like why these two formulas are different.
Uh,
What?
Hello?
Yeah, I'm coming. I'm trying to find a better way to explain to you.
Okay. Hello?
Yeah.
I'm still don't understand like why they are different between two formulas.
Wait, do you understand now?
No.
Okay. Come.
Yes?
Okay. I'm back.
Hello?
Uh, yeah. Hello.
Yes, I can hear you now.
I took the example of we got a certain number of dice. We got 4 dice with exactly pay faces. For example, 6 faces if you want. Okay. We're going to roll each dice one time, and then you see the face which appear, and we try to get the maximum value of all the face which appear at top. And now we check the probability that this is equal to x max any given value. We already got the formula here, so I just have to apply it in our case. You follow me till here?
Okay, please give me a moment so I can have a look at the formula. So, x max divided by k and x max minus 1.
The same thing.
Yes, I got this part, but then oh,
Okay.
because okay, let me try to explain to see if I got it. Because
Okay.
we have this and this, so it basically a loop, so it equal like power n, right?
Yes, because it is a constant value, so y will be at power n. In that case, not n. Okay.
So instead of like power n, we can do this for loop, because from what I understand, the way you write this like this, it's a for loop, right? Oh,
Yeah, it is a kind of for loop. Yeah,
mm-hmm.
with product applied.
Okay. Okay, I
In that
see.
case, power 4 times. Or in the exercise they gave, the function they ask you to write, this value is not constant because it depends of the I. To why we can't raise it at power n in our case. You got it?
Yeah, because if we put 4 here, that is still the same formula, right?
Yeah, it's the same for.
Oh,
This one, it is x max divided by p times the same thing 4 times.
oh, okay, yes. So if it's for loop, then okay, that is equal. Oh, okay, I see now. Okay, I got it. Let me try to go back to my notebook, then we can continue.
Okay, great.
Mm. Where's my notebook? Let's see. Where is it? Okay. Okay. So we have the value of upper and the lower. So we just add up this, right? Basically, what?
We just, yeah.
Okay. Else break. Okay, I understand this. I understand it now. Okay, I understand it now.
Okay.
Oh, it was so long. Finally, I understand it. So you still have time. We can continue to problem 4.
Yes, we can, but it's not yet working.
Oh, okay. Let me try it then.
My side is not working.
Loop. Invalid syntax. Let me.
Add a closing bracket at the
Sorry?
end. Closing bracket. A closing bracket is missing. Yeah. Let me explain you the second function. The second thing they did. No, the second one. Yeah, that one.
Oh,
Yeah.
this one it doesn't run yet because let me try. It's have the
Yeah, there are some mistakes.
yeah. So
Yeah,
let
there
me
is
fix
some
it.
mistakes.
Okay, let me fix it. No, because it's just indent from Colab. They always have issue like that.
Okay. The S should be indent. The S. Yes. The S too. The S also.
Where
Indent
is
the S. Before the break. Else.
let me.
The else statement. Indent the else statement. Okay. Yeah. Yeah. It is a range. So the first thing we should do is to be sure that we got a list. So before that, add a line. F equals list F.
at the first line of the function, write f equals list of f.
Is it?
The first line, add an empty line. Yeah, f equals list of f.
Sorry, I don't get it. What is f required?
List equals list. L-E-S-T, L-I-S-T.
Oh, okay.
No.
Yeah, I'll let you control. Sorry, the voice.
Equals list.
Okay. Yeah, can you try to?
What I'm trying to do.
Okay.
Have a look in the chat. You see the chat? Okay. Wait.
Oh,
Okay.
yes. So
I
what?
have to add the same thing in my function. It is missing it. Making sure that we got a list.
So you convert
yeah.
it to list, right?
You said?
You convert it to list, right?
Yeah.
Okay.
You see what you are doing there? If you run my function, then you run their function. It is their function you are using for the test.
No,
not
I
mine.
know.
Okay, great.
You see, like your function is still doesn't work. But let me have a look at
There is
that.
something. You see there? X max minus. Go in my function. I will show you the way. Show you the error. Just below. Just below in my function, please. Okay. Use put the x max minus 1 between brackets.
Oh, okay. Could be. Good catch.
Priority of operation. Why isn't it working? I will check it later.
Okay, sure. Let's have a look at the function in the example. Okay.
They saw the value before, but I don't think that is why it's not working.
Fix.
Okay, let's sort it to see what it gives.
Oh, they didn't power for. Oh, okay, here they power this. Okay. Okay, I understand. Okay, I got it now. So let's go to problem 4. Write function face that has vector f. Hello? Hello?
Yeah, Trump.
Yes, sorry, I think I got disconnected. So let's
Okay.
try to read this.
La dernière fois, je suis parti là-bas. Au début, je venais, ma grand-mère, quand elle cuisinait, le bol Un grand bol comme ça. Non, attends, c'est les grands bols là. Je te jure, ce qu'elle me mettait dans le bol là. Je ne pouvais même pas finir le tiers de le bol. Au début. Mais quand je dirais là-bas, elle a mené le bol, je mangeais tout. Je dis, mais attends, comment il y a eu le changement en si peu de temps? J'avais fait que deux semaines. Je mangeais autant, mec. Je ne sais pas si c'est les aliments qui sont pas les mêmes.
Mike, I think
Yeah.
I need some time to read this one and analyze it. So could we meet again on the Wednesday? On the Wednesday?
Wednesday.
Pardon?
You said Wednesday.
Yes, because tomorrow I have a meeting with the school, so they have the
Okay.
student program. So I have to wait until Wednesday to meet you to finish this. So I'll have a look at this and we will finish this on Wednesday. But maybe in the few last minutes, can you just explain to me like what they want me to do in here?
Okay, sure. I will have a look on it and explain to you.
You got me?
Yes.
Okay, great. So see you to Wednesday.
Oh no! I meant like, could you explain for me what they want me to do in here?
Oh, now.
Yes,
Okay.
because I want
Is it-
to, so that I can thinking of the problem, and on Wednesday I'll be more productive to discuss it with you. Right now I don't know.
Okay. Okay, I see.
They said write a function face sum that takes a vector f that has the previous problem, represents the number of faces of each type, and the positive integer s, and returns the probability that the sum of the top faces observed is s. For example, if f equals 3, 4, 5, and s less or equal than 2, and s is greater or equal than 13, face sum returns 0. And if s equals 3 or s equals 12, it returns 1 divided by 3 times 1 divided by 4 times 1 divided by 5. The constraint composition function you wrote for an ALO problem may prove handy. Constraint composition function. Okay. The function we wrote above to the larger space. Okay. Okay. What they are asking you is to take. Okay, we roll each dice. We got the top face, the number of the top face. We compute the sum, and then we compare this sum to a given value s. If it is equal to that, we got an equality. Tram, you got me?
Yes, please continue. I'm still listening. Hello?
Okay.
Yes.
Yeah.
Mhm.
In this experiment, they are asking you to compute the probability that the sum of the top faces is equal to a given value s.
Mhm.
Yeah.
The sum of the top.
For example, in that
faces.
case, if you make the sum of the top, yeah, it
Oh,
is
so-
4 plus 3, 7
Sorry.
plus 5, 12.
So this is the sum of the top face, right? The 30. This is the sum of top face, right? The 30.
No, they just give a random value, 30, and they ask you to compute the probability that the sum of these equal to 13. This is possible, for example, if we got 5, 5, and 3, we got 13.
Oh, okay.
But there are also many cases, so you should try a way to count the number of cases possible and divide it by the sample, the length of the sample space.
Ah, okay, I see. Okay,
The length of the sample space, it is the. You will do it?
yeah,
Can
I
we?
think so. So hang on, let me double check to make sure. So the 13, so I need to break down into which element it compute from, right? So basically, it's more like a tree, right? So 13, and I have to find the possible child of the 13, right? Is it the one?
Yeah, but not manually. You should find to use for loop or if statement
Okay.
to compute it.
Okay, so basically I need to find the child node that compute to the 13. So is it like a reversal tree? No, that doesn't make sense. Is it what I got? For example, if they give me the value 13 and I'll find the element that make up for the 13, right?
You said?
Right?
Yeah, Tram.
So if the value is 13, then I need to find what make up for the value of 13, right?
Yes, you should find these possible values,
Ah, okay,
but
I
not
got it.
only this. Okay.
Yes. Okay, so I'll see you on Wednesday. We will continue this lesson.
Okay.
Okay, thank you so
Great.
much. Bye-bye.
Have a nice
See you.
day.
Yes.
Bye. Thanks.
Bye.
Thanks.